Hello and then welcome back to Kafui Klass once again. Today I have seven sets of mathematical questions before our historical class, which will be covering the NCBWA today. The first question, as we can all see, is on the board. And then the first question reads that if 2 to the power n is equal to y, then we have to find 2 to the power 2 plus n on 3. We can see clearly this is a concept of indices. And so what we do from here is to try as much as possible to get 2 to the power n in this particular instance. And then we know from indices that this can be expressed as 2 to the power 2 times 2 n on 3. And then at the same time, from indices, when we look at the loss of powers, we can express this as 2 to the power 2 times 2 to the power n times 1 on 3. 2 squared 4, 2 to the power n from the question y to the power 1 on 3. And so we have the answer for question 1 as simple as what we have on the board. I think just 3 steps and then you get to the final answer. These are not questions that are difficult, but they require some kind of critical thinking and then some assumptions and then some, conjecturing. Yeah. All right. The second question also is similar. If 5 to the power n is equal to k, then we are supposed to find 5 to the power n plus 1 in terms of k. So we are supposed to find this in terms of k. And again, we work with this side. Try as much as possible to get 5 to the power n isolated, which is 5 to the power n loss of indices times 5 to the power 1. 5, 1, 5. What is the value of 5 to the power n? That is k. And so we get 5k. Also, another simple question. So you now understand why I have 7 questions for today, because these 2 questions are kind of a bit simpler. That is why you see me having 7 questions today. Yeah, the third question from the screen also is a bit maybe simple. A rectangle is 3x plus 2 centimeters long. 3x plus 2 centimeters long and then 5 centimeters wide. If a square has the same perimeter, and so the perimeter of this is going to be 2l plus 2b, it is the same as that of the square, which is 4s or 4l. Then what is the length of the side of the square? And so if this is our square as well, so if this is our square as well, we have this concept. We want to make good use of it. We have been told that the rectangle has got the length to be 3x plus 2, and then the breadth or the width of the rectangle was given as 5 centimeters. And so we just do a bit of substitution, or possibly equate the two. Since the perimeters are said to be the same, then we should have 2 of the l plus b being equal to 4s. Perimeter of square all around 4s or the 4l. This is going to be l plus b 2s. We've been asked to find the length of the side of the square. So the length of the side is the s, and so s is equal to l plus b over 2, or half l plus b. What is the value of the l? 3x plus 2. And then what is the value of the b, which is 5? And so we get our s to be 1 on 2 3x plus 7 all centimeters. So this is the length of the side of the square, question 3. And so first 3 questions have been done, not quite technical, but I think the question 4, 5, and 6, 7 are a bit tricky. and then we need to pay close attention to this. So the question 4 also from the screen reads that we have a semicircle PQR, and then the PQR we have 16 centimeters here, another 12, is it 12? Yes, 12 centimeters, that is QR. In the diagram, PQR is a semicircle. If P, the length of PQ is equal to 16 and then the length of QR is equal to 12, calculate correct to three significant figures. A, the radius of the circle. And then we know radius should be half of the semicircle. So when we take the semicircle, the distance from the center of the semicircle to any point of the semicircle or the circumference should be the radius. And so if that is a concept that has been established, we can assume that from here to here should be radius. But before we get the radius, this from here to here is radius, from here to here is radius, from here to here is what we call the diameter. And the diameter divided by 2 is what gives us our radius. This is clearly the picture of right angle triangle. And so our right angle triangle has this nature: 90 here, 12 here, and then probably 16 here. We can find this side, which is the hypotenuse, say y. And so if you're able to get y, then it makes it a bit easier for us to be able to find the radius. Alright, so 16 squared, y squared is equal to 16 squared plus 12 squared. Hypotenuse, Pythagoras theorem. So y squared, 16 squared, 36, 3, 6, 1, 6, 9, 6, 1, 6 here. This is going to be 15, so 5. This is going to be 2. So 2, 5, 6 plus 144. Now y squared is equal to, this is going to give us 400 centimeters, or centimeter squared. And then we find the square root of this, which is going to be 400 cm squared. And then from all indications, we know the square root of 400 is 20. And so we have 20 centimeters for our y, which is the diameter. And so the radius is going to be y on 2, which is 20 on 2. And then that gives us 10 centimeters. So that is the radius of the semicircle we have on the board. Then the next one says we should find the area of the shaded part. And so the area of the shaded part should be the area of the semicircle minus the area of the triangle PQR. So area of our semicircle that is half pi r squared. Since the area of a circle is pi r squared, half of the pi r squared should be the area of the semicircle. Now we know pi to be 22/7. We know our radius to be 10. So 10, 10, 100. Yes, so from here 2 here 1, 2 here 11. We get 11 times 100/7, which is 1100 all over 7, if I'm not mistaken. So let me just confirm with the calculator. And it's supposed to be correct to three significant figures as well. So 11 times 100 is just that is 1100, and then divided by 7. That should be giving us 157.143 cm squared. That is it for the semicircle. Okay, but with three significant figures, 157 cm squared. Now we take the area of the triangle. Area of the triangle, half base times height. So triangle PQR 1 2 BH. The base is 12. The height is so our height is 16. 1 over 2, 16, 12. 2 here, 1, 2 into 16, 8. 8 times 12, 8, 10, 80, 11, 88, 12, 96. So 96 cm squared. Now, finding the area of the shaded region or the shaded portion now becomes the first one minus the second one. So area of the shaded portion now 157 cm squared minus 96 cm squared. 15796. 1 is it 6? So 61 centimeters squared. So the area of the shaded region is 61 centimeter squared. Yeah. Now the last the question 5. Because I'm used to solving 4 and 5 questions, I'm saying the last question. So question 5 says that without using mathematical tables or calculator, simplify half log into brackets 25 on 4 base 10 minus 2 log 4 on 5 base 10 and then plus log 320 on 15 base 10. Sorry, on 125 base 10. 125 base 10. Yes, so we've been asked not to use mathematical tables or the calculator. So the right approach needs to be taken. Now, from the laws of logarithm, we can write this as log 25 on 4 base 10 raised to the power 1 over 2. And then this also can be written as log base 10 4 on 5 also to the power 2. And then this can also be written as log, let's maintain the 320 10 like this. Okay, now this is a perfect square, this is also a perfect square. And then since I have two perfect squares, I can write this as 5 squared 2 squared all to the power half minus log. This is also going to give me either I can leave it as 16 on 25. Now somebody will ask, why are you simplifying this and you're rather why are you increasing this and reducing this? It's because of this half here. So let's take note. Now this is going to take care of this, this is also going to take care of this, and so we have log base 10 5 on 2 minus log 16 on 25 base 10 plus log 320 on 125 base 10. Yes, so this is what we have now. And then from the laws of logarithm again, when we have the log subtracting, we can divide them. So this is going to be log base 10 5 on 2. This is not going to become a situation of multiplication later. So 16 on 25, and then this is a plus, so it becomes times 320 on 125. Now I change the division to multiplication and I reciprocate the numbers here. So 5 on 2 times 25 on 16 times 320 on 125. Oh, okay. So 5 here, 1, 5 here, 15. Um, 5 here, 3, 5 here, 5, 2 here, 1, 2 here, 160. Yeah, 16 here, 1, 16 here, 10. So I'm left with log base 10, 1 times 5 times 10 on 3. So this, hey, sorry. So 5 times this, okay. Let's just check if everything is intact. So 16 goes here, 20, and then 2 goes here, 10, okay. 5 here, 1, 5 here, no, yeah, so 5 here, 15. Oh, no, 25, 5, 7. This should be, I think, 25 rather. So 25, 5 here, 1, 5 here, 5. So that the 5 would come down here. So this is going to be 5 here, and then this will be 1. Please, to be honest, if I start, let me take it again. I'm getting myself confused. So sorry. It is all part of the business. It's part of the yeah. So 5 on 2 times 25 on 16 times 320 on 125. Now step by step. 16 here, 1, 16 here, 20. That is 6 times 2, 32. So times 20, 620. So 120. 2 here, 1, 2 here, 10. I have log base 10 of 5 here, 25, and then 10, all on 1, 2, 5. Yeah, so this is what I'm supposed to get. Challenge better. And better, but when you can't give up just like that. Yeah, so this is here. No, Yinya log 5 times 25 times 10 on 125, all base 10. Into 5 times 25 air 120, 5 times 25 air 125. The 125 beta 125 naka log 10 base 10, which is equal to log 10 to the power 1 this 1 log 10 base 10, which is equal to 1. So the final answer for all this rubbish is just 1. So the examiner knows that the final answer is 1, but they will stress students to get an answer. Or sometimes they frustrate students and the students will end up getting different answers altogether. But if you don't pass through this process, you might not get to wherever you want to get to. So sometimes you just have to endure the pains and then do it once and for all. It is better than going for a receipt or something. But I'm not saying if you go for a receipt you're a bad student. No. Sometimes circumstances may not permit you to do what you want to do, but just manage. All right. Question 6. Given that log p is equal to x and log q is equal to y, log p equals x, log q equals y. We've been asked to express log pq on 1000 in terms of x and y. This is very, 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 very straightforward. From the laws of indices, this is log pq. Since there is no base given, it is in terms of base 10 minus log 1000. Now log pq, p and q multiplication, and so this is going to be log p plus log q minus log 10 to the power 3, which is 1000. So from here, log p was giving us x and then log q was giving us y. So I have x plus y, and then this is going to be minus 3 log 10. Log 10 base 10 is equal to 1. And so basically this becomes x plus y minus 3. Yes, question 7. Make Q the subject of the relation R is equal to F on 2 plus F squared on 4 plus Q squared all to the power half. Wow, so this is where the question itself is. So this particular question you are seeing, I intentionally placed it at the last part because I felt it was going to be a bit technical and it will need more time to be done. And so personally, when I'm writing any examination, I try to do the less difficult questions before I go to the kind of difficult questions so that I will have enough time for the difficult one. Yes, so we move this to this, and since we are interested in making Q the subject, R minus F on 2 is equal to F squared on 4 plus Q squared half, like this. This is the same as square root. 1 over 2 is the same as square root, and so this becomes when we square this or multiply by 2, or yes, so all raised to the power 2 will take care of this, and then here is also affected. So we have a concept like this. Yeah, and then from here straightforward, I want to bring this to the left side, this to the right side. So I have F squared on 4 plus Q squared is equal to R minus F on 2 all squared. Yes, I'm not going to be in a hurry to expand this side because I'm looking for something, so I want to maintain this for now. From here I make Q stand here as Q squared is equal to R minus F on 2 all squared minus F squared on 4. Now from here we are going to perform some magic. Okay, I can see difference of, no, I'm not seeing difference of, I can see perfect squares on the board. F squared is a perfect square, 4 is a perfect square, and so it would be appropriate if I try to express this as F on 2 all squared, which is F squared on 2 squared. 2 squared is 4, and so F on 2 all squared is the same as F squared on 4. Now from here I have Q squared giving me, I want to make Q the subject, and so square root R minus F on 2 yeah, so this is what I'm having at the end of the day. Q is equal to R minus F on 2 all squared minus F on 2 all squared. So somebody will say that why didn't you work with the difference of two squares, or let's say the perfect squares that you're talking about? You just did it for doing sake. No, now I have a difference of two squares in this particular instance, and so this is further going to go as R minus F on 2 from the properties of difference of two squares. A squared is equal to A squared minus B squared, A plus B, A minus B. And so I have R minus F minus F on 2, and then by R minus F plus F on 2. So this is what I have, and this is what I mean by difference of two squares. R is going to stand, and then LCM 2, so we have minus 2F, which now becomes a minus F, and then this is going to be LCM 2, so R here, this is going to be R minus F plus F on 2. Q root of r minus f by r. So this is the final answer that we are supposed to get, or we're supposed to get. So you get r squared minus rf. This is the final answer. All right, so thank you so much for spending your quality time to go through all the stress that I took you through today. But if you really enjoyed watching this one, then look out for the other video on the channel, and then I hope you are going to enjoy it. Thank you.